Hey guys, it's been a while since we've had a proper video, and it's immediately an important one. The release of the new QuinLED Dig-Next-2 controller. A new generation of LED controllers. We've had the Dig-To-Go, Dig-Uno, Dig-Quad and Dig-Octa for a while now, and while I do keep those designs up to date, the Dig-Next-2 is a full redesign with the DNA of QuinLED, but improving it to the next generation hardware in regards to circuit design and features. So let's take a look together what makes this controller better than any that have come before it. At least in my opinion. To start off, don't worry, this controller isn't meant to replace the Dig-Uno or Dig-Quad. It's targeted at a somewhat different segment, and in other ways it's a bit of a hybrid mishmash between the two, so it'll exist in parallel with my other controllers. But then, what makes it different, and what is it for? Well, the Dig-Next-2 is meant to be the ideal controller for when you want an all-in-one controller in your LED setup, and you don't want to mess with custom control boxes and such. For this, just like the Dig-To-Go before it, the Dig-Next-2 has a fully custom-made plastic housing. Both the PCB and the housing have been designed by me to try and make it ideal for the function it was intended for: driving addressable LEDs. In regards to where this Dig-Next-2 slots in, this is meant for smaller to medium-sized deployments. For driving these addressable LEDs, the Dig-Next-2 has two independent data output channels which use a newly designed level shifter output stage. On the Dig-Uno, Quad and Octa, we've had the resistor switchers for a while now, but this new circuit should make such a switch not needed anymore and still perform very well in various setups and installs. You can expect up to 10 meters from the controller to your LEDs to basically always work fine data-wise, but in practice it'll often reach even further than that. Another upgrade is that these data outputs have extra ESD protection hardware, and on top of that now also have over voltage protection. The ESD protection will help in the case of lightning strikes or static electricity to try and keep the controller hardware alive, but the over voltage protection means that even if you dead short the data output with 48 volt, it will survive this, and once the short is removed, keep on functioning like it did before. Why up to 48 volt? Well, the Dig-Next-2 features a completely redesigned DC-DC circuit, which makes it one of the first controllers to support a true and auto 5 volt to 48 volt input. The true in that sense means that it will remain functional and output 5.12 volt to its internal circuits and the level shifters, even in challenging conditions when running 5 volt, such as quickly varying LED patterns that can cause voltage drop on the cable to the controller, or even from lesser quality power supplies. So even if the voltage drops below 4 volt, the controller will remain fully functional and stable, unlike some other designs. The pre-assembled Dig-Uno Quad Octa boards have also had such a circuit for a while now, which I believe has contributed to the QuinLED boards being one of the most stable available. Staying with DC power, this controller of course has the signature feature of all QuinLED hardware: built-in fuses. The controller has 3 times positive and 3 times ground power output terminals, and I firmly believe you should fuse each individual outgoing power wire. So the Dig-Next-2, this guy, has 3 internal fuses, 1 for each positive power output terminal. These are divided in 2 times 5 amp and 1 times a 10 amp fuse, and come pre-installed in every Dig-Next-2, making it ideally suited for 2 edge injections with 1 middle injection. For 5 volt strip, this allows you to run up to 10 meters of LED strip properly injected, but with 24 volt, this extends up to 20 meters just from this little controller. I've made sure to have extensive guides available, including a wiring guide, which explains how to wire this up perfectly for 5 volt, 12 volt and 24 volt situations for strips and pixels. If you're starting out using WLED and controllers, I'm hoping these guides will provide you with lots of information to get you set up working quickly and properly for the first time. And well, to make sure you know what's going on, each of the outputs has a broken fuse indicator light letting you know when a fuse might be blown. Next to that, to further protect the controller, it has various internal auto reset fuses to make sure that even in a bad situation, nothing bad will happen to the controller. And lastly, for the DC side of things in regards to power, this controller has another trick. It will actually pay for itself over time. What? How? Well, each of the 3 positive outputs which are connected to the fuses I mentioned before have a DC relay circuit built in, which will fully cut off power to the LED strip when it's turned off in software. This cuts off the idle current digital LEDs use, and since they are off for a long period during the day, this can result in significant power savings. Over multiple years, this can accumulate to such an amount that the controller was effectively free. Next to the DC relays inside, it still retains some other features from my Dig-Uno, Quad and Octa series of controllers, and that's dual power input capabilities with an AC relay output capability. It's supported to have the main input connected with a large 5 to 48 volt power supply. Make sure to match the voltage specifications of the LEDs you are connecting, and you can have a 5 volt USB-C input connected at the same time. By connecting both, the controller will stay alive even when you turn off the large main input power supply using the dedicated relay output port. The what? The dedicated relay output port. This port is in the form of a pluggable connector, and the cable for this comes with every controller. I even made sure to have this custom made with some nice silicone wires. This will provide an always 5 volt, even if you have, for instance, 24 volt LEDs and a power supply, out with 5 volt trigger and ground. Simply screw the leads into your relay board, run the AC hot of the main power supply through the relay, and it will be automatically turned on and off with the LEDs. But the features don't stop there. I mean, look at this PCB. It is jam-packed. The Dig-Next-2 has a built-in digital microphone, allowing you to easily use audio reactive effects. And it has various expansion options. It has a dedicated 4-pin terminal, so you can easily connect buttons or switches to the controller. And to expand that even further, the controller has an I2C port for accessories, which you might have seen on more of my recent controllers. But the Dig-Next-2 also has another port for the first time, which I've dubbed QEXT. The QEXT port has 4 times GPIO pins together with 3.3 volt and ground, and again an included breakout cable with female DuPont style connections, again with silicone wires. This enables the connection of even more buttons, but also sensors and potentially other forms of expansion boards in the future. Wink wink. All in all, a very complete package, even if I do say so myself. And connecting it is easier than ever with the color-coded large terminals, allowing up to 12 gauge wire with a wire ferrule on the input side and up to 14 gauge with a wire ferrule on the output side. So if you're running 5 volt or longer distances, you can connect the appropriate wire diameter to the controller, and combined with the user replaceable fuses, run a well-performing and, even more important, safe setup to run 24/7. We're almost done with the features, but there is also an optional add-on in the form of a mounting plate you can screw down or use some hook and loop tape to attach it to somewhere that the controller clicks into, making mounting easier than with just the bare controller. This optional add-on comes with a screw-in DIN rail clip for when you want to use the controller inside of a DIN rail cabinet. I really looked towards the future with this controller. So it comes with 8 megabytes of flash storage instead of 4 megabytes and 2 megabytes of additional PSRAM. This controller has been in design and testing for about 1.5 years, and although I wanted to release it last year already, it's taking a bit of extra time to make sure it's done right. Doing stuff like this case and everything takes a bit of time. But with modest pride, I am happy to announce the Dig-Next-2 is available at the time of publishing this video from the worldwide store, Dr. Z's for US, Jerem's for Canada local, and for the first time ever, the QuinLED shop in the Netherlands. I've finally been able to work through all the bureaucracy. I can't even say the word, but together with netwerkwinkel.com, we've opened a dedicated NL shop for the QuinLED items. It's going to start off slow with just a few items available, but during this year, I hope to expand this more and more. The Dig-Next-2 is the first item available from the shop, so if you live in the Netherlands, no fear, you can order directly from a local Netherlands warehouse right after watching this video. And with that, I think enough has been said about this little guy. If you've been looking for a Dig Uno quad hybrid that comes with a nice case and up to 48 volt support, multiple fused power outputs that have built-in relays, expansion options, and a built-in microphone, hey, maybe you did. This is the perfect controller for small to medium setups. Look no further. This is it. Okay, after rambling off that many features, I think I need to lie down now. So thank you so much for watching. Comments and questions are always welcome in the video comments or on the Discord server. If you do need a new controller and pick up the Dig-Next-2, that is very, very much appreciated. Bye-bye.